Hello and welcome to our last video of this section. The back page or next page has 8 problems. I'm just going to do the odd questions for now. Your homework assignment is going to be another page where I'm going to ask you to do the odd questions to them. The directions say find the value of the trig function indicated. They don't give us any sort of picture. They just give you a prompt that says find the tangent of theta if the cosine of theta equals 3/5. What can we do with this information? Well, there's a lot of information stored in cosine of theta equals 3/5. So let's unlock what that means. What I'm going to do is I'm just going to draw a right triangle as best as I can, label my right angle, label a reference angle. Cosine of theta equals 3/5. My reference angle is there to show me how to mark the rest of my triangle. Cosine would be opposite, no, I'm just kidding, would be adjacent over hypotenuse. So sine, cosine, and tangent, this is double check. So is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So let's do adjacent over hypotenuse. So this is the adjacent and this is the hypotenuse, how I'm going to mark that. Because why? Because of cosine. Next, I want to find the tangent of theta. Tangent is the opposite side over the adjacent side. If we only knew what the opposite side was, we'd be able to find it. So I'm going to write a little bit here. The tangent of theta equals the opposite side over the adjacent side. We know the adjacent side is 3. We don't know what the opposite side is equal to. What we can do to find this is use the Pythagorean theorem. A squared plus b squared equals c squared. 9 plus b squared equals 25. Subtract the 9 from both sides. Square root both sides and only take the primary answer. It looks like the value of b is 4. So what we can next do is now figure out what the tangent of theta is. The tangent is opposite over adjacent. So the tangent of theta is 4/3. And this is our answer. So what we want to do in this type of situation, draw a picture, label it as much as you can using the definitions for your trig ratios. Then figure out what you're trying to find and what's missing, and use whatever you can to do that, whether it's Pythagorean theorem or something else that we've learned. You can make your triangles all the same every time. You don't necessarily need to label them with A's, B's, and C's because we don't have any sort of knowledge of A's, B's, and C's in here. They just give us a prompt that says find the sine. Now what is sine? Sine of theta is opposite over hypotenuse. If the cotangent of theta is 2/5, mark theta in one of the acute angles. Now the cotangent was adjacent over opposite. So the adjacent side I'm going to mark with a 2 and the opposite side I'm going to mark with a 5. What's missing is our hypotenuse. We know the opposite side is 5, but we don't know what the hypotenuse is. What we're going to need to do to find it is, again, use your Pythagorean theorem. Always you want to know what the exact lengths are with rationalized denominators. We're going to call our hypotenuse c. So let's see, we got 4 plus 25 equals c squared. 29 equals c squared, so the square root of 29 equals c. No longer am I going to do the plus minus because we're talking about lengths of right triangles which are only positive. So we have the square root of 29 here. So the sine of theta is opposite over hypotenuse. The problem with this answer is, what we said is, we need to have rationalized denominators. We're going to multiply by root 29 over root 29. Our final and best answer is 5 root 29 divided by 29. And this is our answer for number 3. So you can kind of see how we set these up, how we use the information that was given to us in our trig ratio definitions. But again, we're going to always need to draw a picture and mark a reference angle here. Now the sine of theta is 12 over 13. Find the cotangent. The cotangent of theta now is the reciprocal of tangent. Tangent was opposite over adjacent, so that's adjacent over opposite. Sine represents opposite over hypotenuse. Mark the opposite side and the hypotenuse. What we're going to do is we're missing the adjacent side. We know the opposite side is 12. We need to find this adjacent side. So we're going to do 12 squared plus, we'll call this b. b squared equals 13 squared. 144 plus b squared equals 169. Why don't we go ahead and subtract 144 from both sides? We get b squared equals 25, or b equals positive 5. Here's our length. Now it's cool because I just noticed something, like when you find the length of a right triangle and it becomes like a whole number, like all three of these lengths are whole numbers, we call that something called a Pythagorean triple. This is the second time it happened in this section. I don't know if you remember, go back to question number 1. This was a Pythagorean triple, a 3, a 4, and a 5, where 3, 4, and 5 are all integer side lengths. We call this one a Pythagorean triple also. This one is really neat to recognize. This one shows up a lot of times in questions. It will save you time if you can recognize that if 2 of your side lengths are 3 and 4, then your third side length could be a 5. It all depends, again, on how things are laid out. 3 and 4 would obviously have to be the lengths of the legs and not a hypotenuse. Or if you have like a leg of 3 and a hypotenuse of 5, then the second leg would be the 4, or vice versa. If you have a hypotenuse of 5 and a leg of 4, the other leg would be 3. This is the last question we'll go over. Find the tangent of theta if the secant of theta equals 5/3. Draw your right triangle. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so we're going to do hypotenuse over adjacent when we label this triangle. The hypotenuse is length 5. The adjacent side is length, wait a second, did that just really happen? We have a leg of 5, we have a leg of 3 and a hypotenuse of 5. This is the Pythagorean triple we saw in question number 1. Automatically I know that this side length is 4 because 3 squared plus 4 squared equals 5 squared. That saved me a bunch of time. The tangent of theta is the opposite over the adjacent, and our answer is 4/3. That saves us a tremendous amount of time. We can always use that to your advantage. This concludes our lesson. The homework will be to work on the odds on a worksheet that I will upload in your assignments. Best of luck. If you have any questions, please feel free to email me. I hope you had a great spring break, but it feels good to be learning again also. Take good care.